Greetings and welcome, friends. Mr. Waddy here. We are going to be talking, this is geometry class, by the way, but we're talking about parallel and perpendicular lines today, and we're going to relate it to distances. And so it's kind of coordinate geometry, but it'll have a little bit of algebra in it. Wonderful. And we were just doing some graphing of lines with the y equals the mx plus b. And M represents slope. I think they saved S for the side of a square. And M is like a slope of a steep mountain. Maybe. I don't know. Man, I love the way I said that. Mountain. And we realized, or maybe you guys already knew this, but here we go. Here's a theorem. Slopes of parallel lines. Theorem. In a coordinate plane, two distinct non-vertical lines are parallel if and only if they have the same slope. So parallelness, parallelity, and same sloppiness, slope. So parallel, and this is if and only if, has the same slope. So m sub 1, Liam, is going to equal m sub 2. So these have the same rise and run. And if these lines are parallel, they will have to have different starting points, different y-intercepts. Otherwise, they would be the same line. And then they said any two vertical lines are parallel. Now, the equations of most lines we have are of the form y equals mx plus b, where m is the slope and b is the y-intercept. Vertical lines are usually x equals some number. I might just call that c for now. Is the equation of a vertical line. And vertical lines, they have no slope, in case you were wondering. They're so steep that their slope is no. Yeah. A horizontal line, by the way, has zero slope, and horizontal lines would be parallel to one another as well. And then there's this interesting property about perpendicular lines, and I've got a little bit of a way I might rephrase this. I'm going to say, actually, you know what? I'm going to do it this way. I'll match their colors. If line 1, let's say, had a slope of a over b, because I think this is a more understanding way to do this, then line 2, Liam and Ryan, will have a slope of the opposite of b over a. And these are referred to as, gentlemen, opposite reciprocals. Where opposite means change the sign. And reciprocal means flip it. You done flip your lid. So, let's see. For starters, I'm going to start at example 2. Example 1, I'm reserving for chapter 4 when we do dilations. In case you're wondering where that is, I have changed its location. I'm not a fan of it in its format, and yeah, so there you go, in your face, example 1. All right, determine which of the lines are parallel and which lines are perpendicular. So let's actually find the slope two different ways here for us. The slope formula, does anyone know the slope formula? That's correct. The slope formula is the change in the y's over the change in the x's. You could think about this as the rise over the run, son. So the change in the y's over the change in the x's. Let's do a formal slope for line A. I'm going to call this m sub a. All right, the slope of line A. We'll use the formula, and then I'll just do rise over run for the rest. So this would be y2 is 3, minus y1 is 2, over 0 is x1, and negative 3 is x2. So if I find that slope, 3 minus 2 is 1, 0 minus a negative 3 is plus 3, I get a slope of 1/3. And notice that is the same thing I would get if I went from one point to the other, if I did up 1 and over 3. rise over run. So those are the same things. So here's the slope formula. There's your example. Now the order matters for slope formula. You can't swap it, otherwise you'll have the opposite of the slope that you're looking for. So there's the slope of line 1. Also, if you're reading the slope off of a graph, like we will with line B here, the way I find the slope is I want to look for what's called lattice points. Lattice points, this is not a lattice point on that line. This is not a lattice. This is not a lattice. Lattice points are points that land directly on the grid of the coordinate plane. And I can find the slope, notice, by going up 1 and over 2 here. So the slope between any two lattice points will be the slope of a line. A line has the same slope all of the time, by the way, in case you don't know. So the slope of line B is a slope of 1/2. And one of the things I want to point out is, let's say I didn't realize there was a closer lattice point. I would actually get the same slope if I went from this lattice point to this lattice point. This would have been up 3 and over 6. And I think you guys agree that 3/6 reduces to 1/2. Right? You with me? Is this all familiar? Am I taking too much explaining? Maybe I am. All right, so slope here, up 1 over 2. So the slope of line, that is not a letter C. C is 1/2. The mic 1/2. And the slope here, some lattice point right there. And where's another lattice point? Maybe this? That looks latticey. Yeah. And so this was down 2 over 1. So slope of line D is -2 over 1, or just -2 is probably the simpler way to put it. So now they ask the question, which of these lines are parallel? B is parallel to C because they have the same slopes. No, they're the same slope, All right, perpendicular lines, are any of them perpendicular? So C is perpendicular to D, and B is perpendicular to D. So these are perpendicular here and here because their slopes are opposite reciprocals. And just to show you the book's way, I'll just verify that. Notice that 1/2 times -1/2. Nope, sorry, -2 over 1, my bad. The 2's would cancel, the 1's cancel-ish, and I'd have -1 left over. That it does, in fact, work out. All right. Brah. I want to get us to some practice time. Oh, guys, you're welcome. I gave you some steps that I wrote out. I don't know if steps are helpful for you or not, but we are going to be doing this activity where we are trying to write the equation of a parallel line. Question, comment, or you just... was that a hurrah sort of... Okay, all right. Hurrah! Yes, excellent. So I tried to give you some instruction here. If I want to write the equation, well, let me, I'm not even going to read these. I'm going to do the example 3, and then we'll reference back to it. I think that'll make more sense. Right? I think you agree, Ryan, right? Like, sometimes just reading a bunch of random steps is just like, why? I don't know what this means. Give me an example. All right. So notice this is the situation, Liam. We are given a point. I'll call this x1 and y1. And I'm looking for the equation of the line passing through the point, this point, that is parallel to this line. Okay? So I've got a line, I've got a point, and we know that there's exactly one line through a point that is parallel to another line. And the equation that I'll look for, I'm going to try to write it in y equals mx plus b form, which is also referred to as slope-intercept form. And there will be two options here, or many options? Many options? Is that a thing? No? Don't? Okay, all right. That was a super offensive thing. I didn't realize alphabetically counting is so offensive. I didn't realize. My apologies. So first thing it says, find the slope of the given line. All right, so they gave us this line. What is the slope of this line? All right, so the slope of line 1 we'll call 2. All right, that line's slope. Now, that line's y-intercept, sure, you guys could tell me that it's -3, but I do not expect that my line's y-intercept is going to be -3. I doubt it. I doubt it, right? Because if they have the same slope and same y-intercept, that's just the same line. That would not be parallel. They'd be intersecting all over the place. Okay. Step 2, since our line is parallel, it will have the same slope. I guess that is like a fact. So I'm going to say, find our line slope. What is our line slope? Slope number 2 going to be? Also the samest of that, right? It's the 2. All right, so I found my slope. We are halfway to solving this problem because for y equals mx plus b, I need 2 pieces of information, the slope and the y-intercept. That is like the DNA of a line that makes a line unique and distinct and look different from other lines. And parallel lines have like a familial trait where because they have the same slope, half of their DNA is the same. They have the similar graphical feature of being parallel. All right, so this is what we're going to do. Now, I've got a point, and I've got to find B. My B is not going to be their B. But this is an ordered pair, x comma y, that will make this equation true, all right, when I plug it in. So I'm going to do the classic algebra of plug in what I know, all right, and solve for what I don't. That's right, that's right. So in y equals mx plus b, I'm going to plug in 1 for y. I'm going to do this over here, is equal to the slope m of 2. An x coordinate that works when y is 1 is -1. And I don't yet know what b is. Right, but I've got to find out where that b is going to be. Right, I could find infinitely many parallel lines to this one by just making a different b, but I'm looking for a particular line that passes through that point. So there's going to be a particular b that makes that work. Oh, you found it? Let's see, then you probably added 2 to both sides. Addition property of equality. You get b equals 3. Guys, we've solved this mystery. We've got the slope in the line. The DNA test came back. And now what they say is write your equation in slope-intercept form using your slope and your y-intercept. Now I'm going to ignore this. I'm going to just write this as y equals 2x plus 3. All right, I want to leave this generically with y and x as y and x. So it represents all possible points that make this equation true, not just this one particular point. All right, so that was version A. Let's check out what version B looks like, which uses still the same strategy up to this point if I find M. The only difference is I'm going to plug it into y minus y1 equals m parentheses x minus x1. So I'm going to show you both of these strategies. You can use either. I think point slope form is the easy way. So watch what I do. I'm going to have y minus y1 is 1. So y minus a positive 1 is y minus 1 equals m, which is 2, which we found the same way earlier. Parentheses x minus x1. X minus a -1, I think you guys agree, would be plus 1. And now what I do is I plug it into point slope form, and then I solve for y, which conveniently rewrites it in slope-intercept form. So to solve, I'm going to distribute. So that's 2x plus 2, right? Because I done did some distributing. Whip, 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 whip. And what would I get? How do I get y by itself over here? And 1. That's right. Bow. And I get y equals. I was at home writing this lesson. But this is a playoff lesson. I've only got one shot at this lesson to record this video. It's amazing. But I heard the game was quite good. Yeah. So that's all we're gonna do today, friends. We'll tell you what. Let me put one more problem up on the screen for our internet friends to try at home if they would like. So there's two possible ways. They both kind of take about the same amount of work. But thanks for watching, and have a great day. Bye-bye.